Alright guys, welcome back into the video notes. We're continuing this unit that we've been dealing with logic and reason. We just introduced proofs, and specifically we just talked about doing that with algebra and something we're a little more comfortable with. We're still going to kind of review and use proofs with things that we've talked about before, but it's going to be specifically things that we've talked about in this class. Okay, so label for today is going to be 3.4, proving addition postulates. So now that we've talked about it with algebra, can we apply this to things we've already talked about in our geometry class? Date today is going to be the 9th or 10th, depending on whenever you have this class. And then objective for today is we want to be able to use the addition postulates that we've talked about before. Remember the segment addition postulate and the angle addition postulate. And we're going to use those to be able to prove different things about, angle measures, variables, things like that. Okay? So first off, making sure we review and have this idea down, I want you to take a second, I want you to pause your video, and I want you to draw this diagram for me. So take a second and pause your video. Alright, so once you have this diagram written down, we're looking at this here. Hopefully you've got all the points labeled, all the side lengths labeled here, and we're just trying to solve for x. So if we forgot with the addition postulates, whether this is segment addition or angle addition, the idea is always the same. The piece plus the piece equals the whole thing. So in this case I have 3x minus 6 is this segment here. I also have 3 right here, and then the whole thing 2x plus 3. So if I want to just solve for x here, not setting up a proof or anything like that just yet, if I want to solve this, I just need to take the two pieces and add them together. So I'm going to have the first piece here, 3x minus 6, plus the second piece, which is 3. And like we said, that should equal the whole thing, which is 2x plus 3 here. So 3x minus 6 plus 3 equals 2x plus 3. And then we can continue to solve like normal. So we have this here. On the left side, I have two numbers that are on the same side of the equation, so I can just combine those here. So 3x, and then when I take a negative 6 plus 3, hopefully we're confident with adding and subtracting negative numbers, but this is going to be negative 3, and then equals 2x plus 3. We continue here. I have 2x on on the right side. I can subtract that to get rid of it. So I'm subtract from both sides, still getting in the habit of showing algebra work. And then 3x minus 2x on the left side is going to be 1x, or just x. So I have x minus 3 equals 3. And then last step here, hopefully we understand, I have x minus 3. So to get rid of that minus 3, I just add 3 to both sides. When I do that, final answer here, I get x equals, and on the right side, I just have 3 plus 3, which is 6 here. So this should be my final answer, and then if I want to go in and check that as well, I can always plug that back in and make sure all these segments added up correctly. We're not going to do it in this case because we're just looking for the variable, but if we're unsure, like I said, always keep that in mind. All right, with that here, we do need to review this postulate that we've talked about and make sure we understand the specific definition that goes with it, and then we're going to use that to be able to fill out these proofs that we introduced last time and be able to talk about that. All right, so I'll move myself down here. First thing, or first postulate that we're going to write down for today is segment addition postulate. Segment addition postulate. And it says this, it says if B is between points A and C, the technical definition says if I just have some point, in this case we'll just call it B, in between two others on a line, A and C, then this statement is going to be true, AB plus BC equals AC. Same way as saying the part plus the part equals the whole thing. But we need to focus in on this piece here because this is the kind of piece that we're going to use on all of our different proofs that we're working through. We have to understand how to show the setup with the names. If I was looking for an example here, we can use the statement that we've already made, so I'm just going to draw what this description was saying or this postulate was saying. So let's say we have one point here, another point here. We can label these A and C like the definition or this description just told us. I have a line in between them. And then in this case, B just has to be between them somewhere. So it doesn't have to be dead in the middle. It just has to be somewhere in between them. So I could throw it to the left side, throw it to the right side, whatever, as long as it's in between them here. And all this is saying is just like we've used on that problem we just worked on. AB plus BC is going to equal the whole thing, AC. We're going to see this idea with segment addition on simpler diagrams today, but in general you want to be able to see that and spot that when the diagrams get more complicated. As long as I see one point in between two others, I always know the piece plus the piece equals the whole thing. And we'll talk about what that looks like and practice that a little bit more today. All right, so example 1 here. We are going to use this to prove what x equals here. So I want you to take a second, I want you to pause your video, and I want you to sketch this diagram for me, and then we'll come back together. Okay, so we're here. Hopefully we have the diagram drawn. We have everything labeled with the points and the side lengths and things like that. And now the question is, how would I prove that x equals -7? And I kind of told you guys this a little bit, that this is the way proofs will look, is you have some given information. In this case, it's just a diagram, and then something that you're always trying to prove. And remember, I'm telling you the final answer. So I'm not saying what is the answer. I'm saying I know the answer is -7. I want you to show me how we would get there. So if we're going to fill out a proof, we're going to set up the same thing that we did in class the other day. We need to set up our 2 columns with statements on the left side and then reasons on the right side. Anytime it says I need to fill out a proof or need to prove something, this is where I'm going to go. Okay? If we're trying to work through this here, where do I start? Remember, the first reason we already talked about is always the same. First reason is always going to be given. Given here. All right? And then on the assignment that you're working on today, I'll specifically have things or side links that are written out that says here's what this side link equals, and you can just copy down the given. In this case, since it's not just written out for us, we're just going to copy down what we see from the diagram. So notice here, this first one here, we see line segment JK. We notice that's 17 plus 2x, so I'm just going to write that in my given information. JK equals 17 plus 2x. All right, next one here, we are told KL is x plus 17. So same thing as before, I'm just going to label this and say KL equals x plus 17. And then finally, the last one here, the whole thing, JL is 13. So I'm going to say JL side length. Remember, putting that segment above the names is going to equal 13 here. And now the question is, how do I prove that x equals -7? Well, in general, we know from the problem that we just did that I can just set these up, piece plus the piece equals the whole thing, plug in my variables and everything like that, and then solve like normal. With proofs, you need to show every single step of your reasoning and need to show how did you get there, how did you get there. So first thing, and basically the main idea with these proofs and how they differ from the problems that we've seen before, is you need to show the setup of the equation just with the names. So if I asked you here first, how would you set up an equation like this if I just had the names of the segments? If I didn't even give you any of the variables or side links at all, how would you set this up just using the names? Well, we know if we're looking at this, we see one piece, which is JK. So I'm going to write that out here for my next statement. JK plus the other piece, KL. Again, not paying attention to the variables. We're focusing on that, just talking about the names of them, equals the whole thing, which in this case we know is called JL. So that statement here is going to be JK plus KL equals JL. Need to say this first. Always need to use the names first before we can go into the actual numbers and the variables. Now that we've shown this setup, the reason for that, well, what does this tell me? How can I do this? Well, we just wrote down that postulate. Remember, the postulate said if I have some point in between two others, then I can write out that equation. So my reasoning for this is going to be segment addition postulate. I'm just going to go ahead and abbreviate each of those words, segment addition postulate. Okay, so we have this here. Now that I've shown the setup with the names, now I can start to plug things in and solve like normal. So we have this here, JK, we already said, is 17 plus 2x, so I'm going to plug that in, 17 plus 2x. KL is x plus 17, so I'm going to plug that in as well, x plus 17, and then equals the whole thing. We've already said in our given information that JL is 13. So that would be my statement that goes with it. What's my reason for that? Well, I just took the name of something, or I just took the variables and numbers that it equaled, and I just plugged it in. Anytime you see or if we just say plug in, anytime you plug any numbers in, that's just going to be substitution. So my reason for that, and remember that one of the properties that we wrote down last class, that's just substitution. And if I wanted to be as specific as possible, I could say substitution property of equality. But in this case, substitution will suffice. Now we have our variables in here. Now we can continue to solve like this, like normal. And now we're just back to the algebraic proofs. So if I have this equation here, I see there's two x terms on the same side of the equation, and I see two numbers on the same side of the equation, remember I can just add those together. So 2x and x, don't subtract one from the other, just add them together. So that's just going to give me 3x. And then 17 and 17, add those together, and that's going to be 34. And then equals 13 here. Okay, what's my reasoning behind that? How do I know that? Well, I have like terms on the same side of the equation, and I just combine them. So that's just combining like terms. This would not be the addition property. Remember, addition property only works when I'm adding something to both sides of the equation. So combine like terms will do just fine. And then we'll continue to scroll down here. We've got a couple more steps. So we see we have 34 on both sides of the equation. I want to subtract that. I'm sorry, on one side of the equation, and I want to subtract it. So when I subtract it, on the left side it would go away, and on the right side I'd have 13 minus 34, which you can do that in your calculator if you'd like, but that's just going to be negative 21. If it helps to write out that minus 34 part, feel free to do that, but the goal with all these proofs is that we're being able to just show the statements themselves, not necessarily all the work behind it. And the reason for that, how did I know I could do that, or why does that work? Well, we subtracted something from both sides, so that's just the subtraction property of equality. Okay, and I am going to abbreviate it sub and then TR, because if I just said sub, that could also mean substitution. So just a little thing there. And then finally we have the statement. We have 3x equals negative 21. So I know I would divide by 3 on both sides. And even if I don't know this in my head, remember, I already give you the answer. I told you what our final statement is going to be. I know x is supposed to equal negative 7. If I get to the end and it doesn't match up, then I need to check my work because something might be wrong there. So I said x equals negative 7, and then what's my reasoning behind that? Well, we divided by the same number on both sides, so that would just be division property of equality, or div prop of equality. And that's the idea behind these proofs. So the only thing that I'm adding into these now, you guys know how to do the algebra, you know how to fill out the proofs. The only thing I'm adding in is just being able to show the setup with the names of them. And you need to do that for every proof. All right, so moving on to the next one here, next postulate, we're going to add this in as well. And we have the angle addition postulate. So we're going to write this down as well. Hopefully this is a little review for you guys. But angle addition postulate. I want you to write this with me. And it says this. It says if we have some line, doesn't matter what it is, we'll say if line or ray AB is between angle, let's call it, I don't know, maybe DBC here. The letters don't really matter. But if ray AB is between angle DBC, then what I can say from this is I can say the piece plus the piece is going to equal the whole thing. So I'm going to say angle, I need to think about the way I would word this, DBA plus angle ABC, and really it's the measures of them, is going to equal the whole thing, which we already said the whole thing is angle DBC. So obviously, to give you a sec to write all that down, it's a lot of letters and it's a little confusing just if I write it this way. So we're going to draw an example with this just to make sure we can visualize this. And hopefully this, like I said, this is a review because we've done this kind of stuff before here. Example. So if I want to draw this, just draw what's in the description. So we start with angle DBC. Doesn't matter what it looks like. Angle DBC. D, B, and C here. And if I want to show or fit this description, I know I have ray AB. So we can just draw that. Doesn't matter where it's going. It could be right next to C. It could be right next to D. Doesn't matter. It just has to be somewhere in between it. And then I would label this A. And what this is saying is just like we've talked about before. The piece plus the piece is always going to equal the whole thing. And it's going to be the same idea that we have to be able to show this setup in our proof and then solve it algebraically. All right, but that's the basic idea with angle addition postulate. So now let's look at this. Example 2 here. What would this look like in a proof? Okay, so I want you to take a sec. I do want you to sketch this diagram for me. As far as writing down the given information and what we're trying to prove, I don't need you to write that because we're just going to include that when we go through our proof. So really all I need you to do is just write in, draw this little diagram here. So now that we have this drawn and we have all the names of things, or the names of the points labeled in here, we have our given information. We're told what all three of the angle measures equal, and by the end I'm going to try to prove that the measure of one of the angles, UVI in this case, is 75 degrees. That's my end goal here. So what we're going to do first is I can set up my proof, statements and reasons. statements on the left, reasons on the right. And then before I even get into this, one other thing that I will recommend as well, if this helps you visualize where those angles are, is I'm going to label what my angle measures are in terms of whatever variable I was told. So if I have angle UVI, I was told that's 11x minus 2. So I'm just going to write this in here in angle UVI, 11x minus 2. I was also told IVW, the other piece, is 5x minus 5. So I'm going to write that in as well, 5x minus 5. And then I was told the whole thing, so I'll just draw a little arc over the whole thing. I was told that's 105 degrees. So I'm just going to label that accordingly. Like I said, this is not necessary or mandatory, but it's something that can help you visualize how to work out these problems and make sure that you're putting everything in the correct spot. So now we're moving on to our proof. We know if we're ever trying to work through this, the first reason is always going to be the same. First reason is always going to be given. So I can go ahead and write that in. And then what do I need to write for my first statement? All I need to do is just copy down exactly what you have after given. I have had some students try this before where they just circled, and I think I mentioned this to one of my classes. I had students just circle it and just draw where it should go. Don't ever do that. Okay, that's just lazy, and we need to make sure we're including everything in our proof. So I just need to copy all this down. So measure of angle UVI equals 11x minus 2. Also told measure of angle IVW is 5x minus 5. Minus 5 here. And then measure of angle UVW, the whole thing, is going to be 105 degrees. So we're just including all that here. And this is all of our given information. So now the question is, I'm here, where do I go next? How do I start filling out the rest of this proof? It's the same thing that we just did in the last one. I want to get to a point where I can just start solving this equation like normal. So 11x minus 2, piece plus piece equals the whole thing, that whole spiel. The only issue is I need to show it with the names first. Always do this first. So if I'm looking at just the names, if I'm looking at the pieces here, I see one piece is angle UVI. So I'm going to write that in, measure of angle UVI plus the measure of the angle of the other piece. If I look here, the other piece is IVW, so plus measure of angle IVW equals the measure of the whole thing, which in this case is UVW. Need to make sure you're putting those letters in the correct spot, or those angles I should say in the correct spot, because that's going to help us and make sure we get our equation right. So we have this here, we've shown the names of them. What's my reason behind that? Well, again, we just wrote that reason down. That's just the angle addition postulate. It says if I have a description like this or a diagram like this and it fits that description, then I can say that the piece plus the piece equals the whole thing. So that's going to be angle addition postulate. I can abbreviate as needed. The reasons angle addition postulate. Now that I've shown this is our main thing that we had to show. Now that we've shown it with the names, now I can start plugging things in and solving like I want to. So we've said UVI already is 11x minus 2. So I'm going to go ahead and write this in, 11x minus 2 plus angle IVW, which we've already said is 5x minus 5, and then equals the whole thing, 105. What's my reason for that? What goes along with that? Well, we already talked about this. Anytime I plug in numbers, anytime I plug in variables, anytime I plug something in, that's always substitution. It's always going to be substitution. And now we're back to algebra. Now we can just solve algebraically like we did on the last lesson. So we have this here. We have these things on the same side of the equation. I can just add those together. So 11x plus 5x is going to give me 16x. And then negative 2 and negative 5 combined together, it's going to give me negative 7. And then the 105 doesn't change. What is my reason behind that? How do I know I can do that? Well, I just combine like terms. Remember, it's not the addition property. Since they're on the same side of the equation, I just combine like terms. And then we continue from here. So we have this 16x minus 7 equals 105. I know I would add 7 to both sides. And when I did that, I'd have 16x equals 112. And my reason behind that, how do I know I did that? I added something to both sides. So that's the addition property of equality. And then final step to find out what x is, if I want to include this here, is we know we would divide by 16 on both sides. In this one, you could just type in your calculator if you'd like. In this case, it didn't just give us what x was. If you type this in your calculator, that's going to be x equals 7. Okay, x equals 7 here. And my reason for that, since we divided, was division property of equality. And usually here, we'd be done. We'd say x equals 7. All right, that's what we're trying to prove. We're good to go. The problem in this case is it wasn't asking us to just solve for x, but it was actually asking us to solve for the measure of an angle. So we did this in the past where we defined what x was and then we plug it back in to find what the measure of whatever it was. We're going to do the same thing here, but we just have to show that in our proof. So what I'm going to do here is, notice we're trying to find the measure of angle UVI. So I'm going to take what UVY used to say, or what that first statement was, UVI equals 11x minus 2. So I'm going to go ahead and kind of rewrite that. Measure of angle UVI equals, and then we said it's 11x plus 2, but now that we know x, we can just plug that in. So we're going to say 11 and then times 7 and then minus 2. Minus 2 here. So notice, just like before, I just plugged something in. I took the statement that I already had in my given and I just plugged 7 in for x. So what's my reason since I plugged something in? That's just going to be substitution again. Substitution again here. And now the last thing that I need to do is I have measure of angle UVI. I'm going to write that again. And then I just need to do the actual math, right? So I have 11 and 7 right next to each other. So hopefully we understand that means multiplication. So that gives me 11 times 7, which is 77. And then minus 2 is going to give me 75. And this is where I was trying to get to. I was trying to show by the end that UVI equals 75 or 75 degrees. Now, what is my reason for this? Well, we multiplied and we subtracted something, but we didn't do that on both sides of the equation. Okay, we also didn't really combine like terms because it's not like we could really combine numbers or we did multiple things. We didn't just add things together, we also multiplied here. So what's my reason for this? Anytime you get to the end of a statement like this where you just did the math, that's what we call simplify. All I need to write here is I just simplified. So I had some statement where I had to do multiple steps and I really just had to do the math. That's just called simplification or simplify. And now we're done with our proof because we've got to the end and we showed that the angle equals 75 and we have reasons for everything. All right. So that is the assignment, or that is the notes for today. Homework for today is going to be 3.3 and that should be posted on the class website. Same thing as always. If you guys have any questions, feel free to let me know. Otherwise, you should be good to go for today. Thanks, guys.